This is the Precalculus Spring 2017 ACP preview, and this set is on vector and vector application problems. There will be 6 problems here. First one here is a vector application problem. Harrison walks to the library after school every day. When Harrison leaves school, he walks 16 blocks due west and then 12 blocks due north to get to the library. What is the magnitude and direction of the resultant vector? Basically what that looks like, we can draw a sketch of that. If we draw kind of an XY coordinate plane, like this, there's our Y, there's our X, and so we call this I'm going to move it over here for north and west. Okay, west by convention is going to be over here to the left, and north will be up above. And so as we go 16 blocks due west, we're going to go, I'll just mark 16 over here rather than count them out, and then 12 blocks due north. And so what we have is, if we kind of look at coordinate pair language, this left to west would be a negative. So this coordinate pair would be like negative 16, comma 12. And then in vector application, our net vector would be this one right here, just drawing from the origin straight to our point of termination. And that's it. And our vector is actually going to be, if we wrote this as a vector, we would write this in component form in angular brackets like this. And this angle right here, theta, is going to be the rotation up from north. So it would be west west 36.9 degrees north. And we've got to kind of look at the language here. So we go west, then north. And so our direction is going to be found by, we take direction. If we look at an angle, we would have our opposite to the side here and our adjacent below. And so our direction will be equal to our inverse tangent of the vertical change, which would be 12, over the horizontal change, which would be negative 16. Now keep in mind, we're going to get a negative angle out of this because that's just what it's going to have to be. And if we put this in our calculator, we're going to get inverse tangent of 12 over negative 16, and we are in degrees, so we get negative 36.9 round to the nearest tenth. So and the thing is, it's given as negative, but that's kind of to be understood. And so we're going to look for this 36.9, and the only place that I see that is going to be answer choice D. No, also answer choice B, excuse me. So what we have to do now is check for magnitude, and so our magnitude is going to be equal to, we're going to take both of these here and square them. We're going to take 12 squared plus negative 16 squared. And where do these things come from? Well, they come from right here. This one, this 12 is the 12 blocks north, and negative 16 is 16 blocks west. So we go to our calculator, and in our calculator, we're going to put in 12 squared plus negative 16. And we should understand that negative 16 squared and 16 squared are the same thing. So we get 20. I think that's a 3, 4, 5 right triangle is what that ends up being. So we get 20. And so between B and D, our correct answer between the two is going to be answer choice B. So that's a nice little direction problem, direction and magnitude problem, application of the vector. Next, if r equals 4 comma negative 2, which graph represents negative 2r? Well, what we can do is we can say negative 2r is equal to, we're going to take negative 2 times this vector 4 comma negative 2. And that is going to be equal to, we just use our distributive property, so we're going to get negative 8 comma, and negative 2 times negative 2 is 4. So we can go, we kind of look where we have negative 8 comma 4, and C looks like it's a candidate, right? This would be in quadrant 2. So if we go 8 to the left, we get right here, and go up 4, we get right here. So our C is going to be our correct answer for problem 15. Should be a pretty easy problem. And this is called the use of what we call a scalar, when you multiply by a vector by coefficients. Next, 16. Well, here we have this kind of, if U equals vector 8 comma 12 comma negative 3, V equals a vector negative 2 comma 7 comma 14, and W equals vector 2 comma negative 5 comma 6. What is 3U minus 4V plus 2W? And this is like a three-dimensional vectors. And in our exercise, I think we only did two-dimensional vectors in class. But if you look at your answer choices very carefully, you will see that each one of these x values is different. And likewise, for these y values, the second term in the vectors, and also the third. So they are all different, meaning that because of our answer choices, we're not going to have to solve this whole thing and get the whole vector. If we just find the first component, we'll be good on that. So what we'll do for 3U, we're just going to take 3 times, and all I'm going to do is take the first component here, which is 8. And then the next thing we have is minus 4V, and that's going to be 4 times this first term here, which is going to be negative 4. And then we have finally plus 2W, so plus 2W, 2, and the first term in there is going to be 2. And so all we have to do is account for all these things here. And we're going to go to the right. We're going to get 3 times 8, which is 24. We're going to have 4 times negative 4, which is going to be negative 16. And then we're going to have 2 times 2, which is 4. And so what we're going to get is, again, we're only doing this for the first value. We're going to have 24 minus 4V, so it's going to be minus negative 16. And 24 minus negative 16 is 40, right? Because it's the same as 24 plus 16, plus another 4, is we get 44. So we can answer choice D without having, if we want to double, triple check, we can try the same thing for the second value in the vector and the third as well. but D is our correct answer for this. Next, 14. An airplane flies east for 200 miles before turning 60 degrees south and flying for 100 miles. And what we're going to do here is put this similar to what we did with that somebody walking. So we set this up like an XY coordinate plane, and here we're going to have east, and we're going to have south here. So we have a plane that flies 200 miles east. So we'll say this is 200 miles. And then turning 60 degrees south. So that's going to be a 60-degree turn, pretty sharp turn here. So we'll go 60 degrees south, and we'll call this 60 degrees here for 100 miles. So what we're interested in finding, we're trying to find out is the new distance I'm drawing in this purple vector here, and we're going to have south so many degrees of east, it looks like the way they're wording it here. East. Yeah. So south 19. Well, if it were like the other problem, it would be south and then 30 degrees that way, which is going to be not too possible. So I think it has to be this one by process of elimination right here. So we're going to look for this angle here. And we can use law of sines and law of cosines if we wanted to. But we're looking for the distance from the beginning. Well, if we go like this and turn 60 degrees toward the south, we're going to continue to go farther out. And so these choices where we get closer, like 173.2 miles, we're going to eliminate those because they cannot be right. So we get the same magnitude for each of these. We're going to continue through with this. We can put these in component form. Our vector here for the airplane going east, we can write down as 200, 0. And for this one, 60 degrees south, we can write this one as 100 cosine negative 60 degrees. And we can write this other coordinate. I'm going to move this over here just to leave a little more room. We can take this other coordinate here, and that's going to be times negative 60 degrees, cosine negative 60 degrees. Then, comma, 100 sine of negative 60 degrees. And when we add these together, we're going to have 200 plus 100 cosine of negative 60 degrees. I happen to know that's going to be 1/2. Plus, and we have 0 plus, so we'll just have 100 sine negative 60 degrees. And we can write this all out in decimalized form using our calculator. So we go to it and we go 200 plus cosine of negative 60 degrees, and we are in degrees mode, and it's going to be plus 100 times cosine of negative 60 degrees. And that's going to be our, get 250. And for the other one, we're going to take 100 times the sine of negative 60 degrees. And we get negative 86.6. So negative 86.6. So 250 negative 86.6. And we can just find our magnitude. So our magnitude is going to be, we're going to take 250 squared plus negative 86.6 squared. We go to our calculator. We get 250 squared plus negative 86.6. And for this, I'm just going to put Control A&S to give us the last thing calculated. And we get 264.6, it looks like. So we go here. And so, yeah, that's going to be either answer choice D or B. And we're just going to have to check between these two. Now for direction, our direction is going to be our inverse tangent of our change in y. So we're going to take this negative 86.6 over 200, or 250, excuse me. So we go to our calculator, we go to inverse tangent of negative 86.6 over 250, and we get negative 19.1 degrees. So we go here, and that certainly is going to be our answer choice B between the two. And yes, you could also use law of cosines for this, and what you'd have is this angle here would be 120 degrees. And so this side, if we let this side be, this angle be C over here, 120 degrees, this would be our, that'd be 200, 100, and this would be little c. And then, so we can use law of cosines. I'll just set up what will be c squared equals 200 squared plus 100 squared minus 2 times 200 times 100 cosine 120 degrees. And you can just put that in numerical solve and then use law of sines to get this angle here, because we would know this side, the sine, this side C over 1 sine 120 is equal to this sine of this angle over 100. So we could set that up pretty easily. So sine of 120 over this side C we've calculated equals the sine of this angle over 100. Let's go to the next problem, 15. This one here is kind of a monstrosity also, but just as we remarked on that earlier problem using scalars, or using scalars, we can look at this too. We have all these different. So we can say 1/3 of A is equal to 1/3, and we'll just take the A value here of -6. And then we have minus 3/2, so 3/2 of B is equal to 3/2 of B is 2. And then finally we have 2C equals 2 times this value for C, which is 28. And so what these equal, when we go to the right, we get 1/3 of -6, so that's going to be -2. We get 3/2, well, 2 over 2 cancel, so we're going to get 3. And then finally, 2 times 28. Well, I think that's going to be 56. So when we go ahead and treat these appropriately, we would have -2 minus 3, which is going to be equal to -5, and -5 plus 2C is going to be 51. So 51 is going to be our correct first value there. And so again, like the other one, we didn't have to work out everything else, and we got this one right. It should be a pretty easy problem. You're going to have one like it pretty similar to that. The last one we're going to look at here is 16. 2 forces act upon an object as shown. What is the approximate magnitude of the resultant force? And this is very similar to a problem like the problem we did in class about this corporal, the stubborn puppy that is held by 2 leashes, and you get a net force by combining these two. And the thing you got to be worried about is this one here below the x-axis, because that's going to require a negative angle. So just going back here, now one thing you have is you have a force of 15 and 12, just an observation. 15 plus 12, and that's going to be equal to 27. So our net force is actually going to have to be on this object less than 27. So it's going to be a maximum of 27. If they were lined up perfectly, it would be a force of 27, but it's not. And so we can cross off answers C and D already. So what we have here is vectors, like we had before for the navigation. We're going to have our vector up here is going to be the component vector form. We're going to put 15 cosine of this angle here, which is 20 degrees, comma, we'll have 15 sine of this angle, 20 degrees. And for this vector below here, and this is where we have to be careful, I mentioned earlier, we're going to have 12 cosine, and we're going to have not 27 degrees, but -27 degrees, because we're rotating south. Now in standard position, I think this would be 333 degrees. If we went around here like this, we would have 333 degrees, which would be the same. But I'm going to put this one here, 12 sine of -27 degrees. And so what that does is that leaves us a big component vector form here of 15 cosine 20 degrees plus 12 cosine -27 degrees, comma 15 sine 20 degrees plus 12 sine -27 degrees. And we can put this in our calculator and get more manageable numbers, I believe. So we go here, we'll put in 15 times cosine 27 degrees. Make sure I get this right here. 20 degrees. Negative 27 degrees is that other one. Okay, let me fix that. 20 degrees plus 12 cosine negative 27 degrees. And we could have put, like I said, 330 degrees. And we are in degrees here, so this is good. So get about 24.79. So go here and put in 24.79. And then we go over and look at the y value. So 15 times sine. I think they're going to cancel each other out pretty well. 20 degrees plus 12 sine negative 27 degrees. We're going to get negative 0.32. So we go here, negative 0.32. And if we do our magnitude, we're going to have, just like this, we're going to have 24.79. I already know what it's going to be, plus negative 0.32 squared. This negative 0.32 is going to affect this thing very little, so we're going to round off very much to answer choice B. And to just be sure in our calculator, if we go to Control Enter, we're going to put in 24.79, and we're going to square that, plus we're going to have negative 0.32, we'll call it, squared. There we have, yes, 24.79. So 24.8 is definitely our correct answer. Anyway, I hope this has been helpful to you. Good luck, and as always, thanks for viewing.